Hi friends! So today is finally the day. I'm going to walk you guys through the no calculator math section of College Board's first SAT test. Now this section used to be kind of difficult for me because I make a lot of careless mistakes, but I kind of developed a method for checking this section that helped me score an 800 on the math section pretty much every single time in the days leading up to the final SAT I took. So I'll try to demonstrate that method and how you can double check yourself during this walkthrough because I think that's one of the most important things. I'm also going to try to give you as big of a skill set as possible to solve these problems, since most of them can be solved in 2 or 3 different ways. But first, I just want to mention that this video is sponsored by Prep Scholar. Prep Scholar is the test company that helped me score 1600 on my SAT. They have really helpful videos on pretty much every single topic you'll need, and they have a huge bank of questions that are really similar to ones on the actual SAT. In my opinion, Prep Scholar's program is one of the best resources you can use besides College Board's official tests, so I really recommend you go check the link out in the description below if you're interested and if you're looking for a paid resource. And I'll get a commission if you end up purchasing their program after clicking on that link. Thanks so much for listening, and let's get into the math section. So this is just your basic solving for a variable given a certain value type equation, and we can use the order of operations to do this. So here we can multiply both sides by 3, then add 1 to both sides, and then plug in a 3 here. So we get 9 plus 1 equals x, so x equals 10. Now, before we move on, ask yourself, how can I check this? So in this case, it's pretty easy. We can just plug 10 back into this, and we should get 3 for k. So 10 minus 1 over 3, that does equal 3. So we're good to go. And then I'd put a little check by that problem. Next one is a complex numbers problem. Thankfully, it's just a sum in this case. So for adding and subtracting complex numbers, you can really just treat the I like it's a variable. You don't have to worry that I equals square root of -1 unless we're dealing with a slightly more complicated problem. So in this case, we just want to distribute this out. So we'd get 7 plus 3i minus 8 plus 9i. Doesn't really make a difference in this case. And then treating our i's like they're just variables, we'd get 12i. And then our constants, we would get -1. So our answer for this one is A. And this one's maybe a little harder to check, but just make sure you check that math one more time. Make sure you didn't miss any distribution. Make sure you're adding up the right thing. So now we've got a little bit of a word problem here. Let's read through this. So on Saturday afternoon, Armand sent M text messages each hour for 5 hours. And Tyrone sent P text messages each hour for 4 hours. Which of the following represents the total number of messages sent by Armand and Tyrone on a Saturday afternoon? So this date is kind of useless. We don't need that. Figuring out what you don't need is one of the most important parts. So in this case, we can just set up kind of a rate problem. So we have Armand sending M texts per hour times 5 hours will be how many texts he sent in that time frame. So we can just say 5M for that. And this process would be the same for Tyrone. So for Tyrone, it would be 4 times P. And look at that, that is one of our answer choices. And for this, we know the other choices are incorrect because this is switching around the rates. And these other two just don't make sense given the context of the problem. We want to add their messages separately, not multiply them together. So I'm pretty confident in that one. And look at that, we got another word problem. This time, Kathy is a repair technician for a phone company. Each week she receives a batch of phones that need repairs. The number of phones she has left to fix at the end of each day can be estimated with this equation, where P is the number of phones left and D is the number of days she's worked that week. What is the meaning of 108 in the equation? So this question brings us to the most important formula in the entirety of SAT math, and that is y equals mx plus b. This is the main form for a linear equation, where the b represents the initial value you have, the m is your slope, and this is the x and y axis. And we can substitute these variables for pretty much anything, and in the case of SAT math, this will be a lot of different things. So here we can see this equation follows the form pretty well, where p is the y, -23d is the mx, and the b is 108. And in this case, the graph looks like a negative slope. So she starts with a certain amount of phones each week, and it goes down as she completes her work. So looking at these answer choices, it makes sense that she starts each week with 108 phones to fix. And that's what this b is going to commonly represent. It's going to be the initial value of whatever the equation is. These two would be referencing m instead. This would be she fixes 23 phones a day, not even per hour, so that's doubly wrong. And completing the repairs within 108 days is also not right. That would be like the x value it takes to get y to 0. So B is our answer there. Pretty confident in this one too. Next, we've got a basic polynomial expression, and we're just going to have to distribute this out and solve. So let's rewrite this. So distributing the negative sign, we have plus x squared y minus 3x y squared plus 3y squared. That's the most important part, is getting those right. Now, the second most important part is matching these guys up correctly, because they're not in order. So here we have these two variables are the same. Doesn't matter how big they are, as long as they look the same. Then we have these two have the same variable base, and then these two are the same. So now we can just add their coefficients up. So we have 2x squared y. These two actually cancel out because we have -3 and 3. And then we have plus 2xy squared. And the one that matches with that is C. To check this one, I would just do it again and be wary of that negative sign and the order of the variables. Now, another word problem. A pediatrician uses the model above to estimate the height of a boy in inches in terms of the boy's age in years between the ages of 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year? So, would you look at that? We already have another y equals mx plus b problem. This time, h is the y, 3 is the slope, a is x, and the b is 28.6. So if we graphed this little boy would be 28.6 inches to start and then be growing 3 inches each year. And this model only works for when he's between 2 and 5 years old, because obviously he won't keep growing that amount forever. We're looking for the increase each year of the boy's height in inches. And these units are important because sometimes they might mix it up on you. This model is in inches. So in this case, our slope, or the rate, or the amount of height per year, is going to be 3. And that's that. And then to check this one, I would just make sure this value seems right in terms of the model we're looking at. So could a little boy grow 3 inches each year? Yeah. Is he going to be growing over a foot each year? I don't think so. So this is probably the one that makes the most sense, realistically, too. All right, this looks chaotic. The formula above gives the monthly payment M needed to pay off a loan P dollars at R% annual interest over N months. Which of the following gives P in terms of M, R, and N? So guess what? We don't really care about any of this. Like, that's kind of all irrelevant. This problem, and a lot of the time problems that look as complicated as this, are just going to be asking you to rearrange this in terms of a different variable. You don't have to understand what any of it means. So in this case, we want to solve for P instead of M. So we just need to rearrange all of this to get P alone. Setting the numerator and denominator equal to dummy variables is going to be very helpful here, so we don't confuse ourselves more than we need to. So in this case, I'm going to set this big numerator equal to x, this big denominator equal to y. And those could literally be called anything. So now we have m equals x over y times p. Now to arrange in terms of p, we would have to multiply both sides by y and divide by x. And that gets p on its own. So now we can plug these crazy things back in for x and y, and we're done. So p equals y is going to be 1 plus r over 1200, and minus 1 over x is going to be the numerator, that crazy thing, times m. And it looks like b is our answer. And we didn't have to really write that out. You can kind of just do this in your head, but it is always good to double check. So a good check for this one is, could we solve back for m and get the same thing? So p times that big clump divided by that big clump. Yep, that equals m. So I'm confident in that one too. All right, so this one's kind of weird. We've got like a ratio question, or maybe like a manipulating expressions question, and we can solve this in a few different ways, and we can do it in multiple ways to check our work. Let's start with like the most straightforward way. We can solve for one of these variables, then plug it back into here, and then cancel out to get just a number. So if we multiply both sides by b, we get a equals 2b. Now if we plug in 2b for a, we get 4b over 2b. Then cross out the b's because those cancel out, and we get 2 as our answer. Now a more convoluted way to do this is to realize that a over b is just the inverse of b over a. So b over a in this equation will be equal to 1/2 because that's the inverse of 2. And then multiply that by 4, and we get 2. So yay, we did it 2 different ways, we got the same answer. I'm pretty confident in that. Now we've got a classic system of equations problem, and these you can also do in more than one way. I'm personally a big fan of the elimination method, so I like to use that whenever possible, but substitution also works, and I'm sure there's other fancy ways to do these. So we'll try it both ways. Let's do elimination first. So for elimination, we're trying to eliminate one of the variables completely by just multiplying or dividing by some number, to preferably just one of the equations, but maybe both. So in this case, I think the easiest route to go is to multiply this entire equation by 3, because then we get 3x and negative 3x, and those will cancel out, and then we'll be able to solve for y. Let's just be really careful when we do this, because we're also going to take a little shortcut and try to move these around so we can add and subtract later. So we're going to go negative 3x, that's this one, then plus 6y, the 3 times 2. Then do not forget to multiply the negative 19 by 3. And we have to do this by hand, which is annoying because it's the no calculator section. So in this case, that would be negative 57. Now, we've got a nice little addition subtraction problem. So if we add these two up, these guys cancel out. We're left with 10y equals negative 80. So our solution for the y variable, at least, is negative 8. Now, we already see that there's only one answer choice that matches, but a good way to double check would be to plug this back in, but an even better way would probably be solving it the other method as well, but that's kind of time consuming. It's all about a balance of not running out of time, but also checking yourself in the best way possible. So really it's up to you how you double check. If I plug the y back into both equations, just really quick, we get negative x equals negative 3, so x equals 3. So upper equation, be careful of those negatives. We get 3x equals 9, so x equals 3. That's a pretty good way to check plugging it into both, but just for kicks and giggles, let's solve it the other way too, just so you guys know how. So if we want to solve with substitution, we've got to isolate one of the variables, and this x is already very close to being isolated. All we have to do is rearrange to have positive 19 on this side and the x on that side. Then we can plug this equation into the first one. So in this case, we would replace the x with 2y plus 19 plus 4y equals negative 23. So we have 6y plus, we already did this before, 57 plus 4y equals negative 23. Then we get negative 80 equals 10y. Y equals negative 8. So we got the same thing like a billion different ways this time. I think we're good to go on this one. Now we've got a function problem. Functions just allow you to write, instead of having x, y as a solution, to write your solution like this, where the x value would be 4, the y value would be 8. So if it helps you, you can write it as y equals ax squared plus 24. And then just like have this as a solution in mind. So in this case, we have this unknown variable a. So we need to solve for this a before we can plug anything in and solve for g of negative 4. But thankfully, we have a solution. We know x and y. So we can just plug in 8 for y, 4 for x, and solve for a first. So we get a equals negative 1. Now we plug the a back in to the g of x equation. And remember, g of x is like saying when x equals negative 4, what is y? So this is what our equation looks like now. We're going to plug in the negative 4 because it's like we're solving for y when x is negative 4. Be careful of those double negative signs. They will get you. Negative 4 times negative 4 is positive 16. Then a minus sign in front. So we have 24 minus 16 equals y. So in this case, y, or g of negative 4, is 8. Now to check yourself for this one, you can try plugging in the point negative 4, 8 back into the equation here, and then you'll also have to make sure you solved for a right. This one's a little more complicated, but it's definitely still good to do that. And biggest mistake will probably come from those negative signs or just not understanding function notation. Right, it's another word problem, and this time it's a pretty clear system of equations problem as well. So in the equations above, B and C represent the price per pound in dollars of beef and chicken, respectively. So beef, chicken, X weeks after July 1st during last summer. We probably don't care about that. What was the price per pound of beef when it was equal to the price per pound of chicken? Okay, so price per pound and price per pound again. So remember, B and C equal the price per pound of each of those things. So we can just set B and C equal to each other. And if we do that, these equations are also going to be set equal to each other. So we would have 2.35 plus 0.25x equals 1.75 plus 0.40x. And this is just kind of tedious and annoying, and you gotta be careful because we don't have a calculator here. But we can subtract the 1.75 from both sides, so that would get us 0.60, and then we can subtract the 0.25x from both sides as well. 0.60 equals 0.15x. Now we've got to divide by 0.15. A trick for divisions like this with decimals is you're allowed to move the decimal place as long as you move it for both the numerator and denominator. So like we can just call this 60 divided by 15, which is much easier, and that's equal to 4. So that is x. Now, this one's really annoying because we have to plug in x equals 4 back into the beef equation because we're trying to find the price per pound of beef. That's our goal here. So we're ultimately solving for b. So I don't know if I have enough room here. We'll go b equals 2.35 plus, and then we know 4 times 0.25 is just going to be 1. Our answer for B is just going to be 3.35. And this one's another terrible one to check, but you could check this by plugging in 3.35 for both B and C, making sure that the x's are the same, and they should be equal to 4, we calculated, for each of those scenarios. And that would be our check for that one. All right, a line in the xy plane passes through the origin and has a slope of 1/7. Which of the following points lies on that line? Guess what it is? It's our best friend, y equals mx plus b. He's back. So in this case, we have to graph it. So we know the line passes through the origin, which is 0, 0. So let's graph that point now. Then we know it has a slope of 1/7. I don't know if I explained this yet, but slope is just going to be rise over run. So we have a rise of 1 and a run of 7. So we go up 1, across 7. This is just a sketch, so it doesn't have to be super accurate. But that's something what our line looks like. I should probably label these, but it's just a sketch. So looking at our points, let's see which one lies on the line. 0, 7 is going to be wrong because we know 0, 0 is our point. So it can't be both simultaneously 0, 0 and 0, 7 unless it's a vertical line, which it's not. 1, 7, we got to be careful with this one because this is x, y. The 1 would be in the x direction, the y in the 7 direction. So that would be like the opposite of the line we have. 7, 7 would be like we have a slope of 1. So that would be like in between the two. So our answer is going to be 14, 2. This is similar to if we had 7, 1, because our next point in the y direction would be 14 here in the x. It's really important to be able to graph these quickly and understand what they mean and have a good idea of what slope is, what this y-intercept is, all that good stuff. To check this, we could literally plug this into the y equals mx plus b equation. So in this case, we'd have 2 equals y, our slope is 1/7, x is 14 in this case, then plus b is 0 because it doesn't start along the y-axis anywhere. 14 divided by 7 equals 2. Perfect. Now, if x is greater than 3, which of the following is equivalent to this ugly fraction? Now, don't get too caught up on the x is greater than 3. I think this whole statement is just trying to tell us that it's not going to be undefined, and that's just the condition they have set, so we know it's not going to be anything crazy undefined divide by 0, because like if x was -3 in this case, we'd have a 1 over 0, which then we have a 1 over 0. That just gets weird. So they're trying to keep things simple for us here. So if in doubt, just try to simplify this as much as you can, because we really don't know what we're looking for yet, but this will probably turn into one of these answers along the way of simplifying it. So let's ignore the 1 for now. Let's pretend we have 1 equals x plus 2 plus 1 equals x plus 3. So to turn these into one bigger fraction, we can do a little cross multiplication of fractions. Thankfully, we have 1s in our numerator, so we can just multiply the first fraction by x plus 3 over x plus 3. This is our original. This is equal to 1. That's still that. Then the second one we can multiply by x plus 2 over x plus 2. So x plus 2 over x plus 2, that's equal to 1. Then times the original. Running off the page here. So we don't really need those 1s anymore. So now the numerators, we can add these together. So we have x plus 3 plus x plus 2. So it's going to be 2x plus 5 over x plus 3 times x plus 2. So now we've simplified that pretty much. I don't think we need to expand this out just yet, because let's just wait and see. And now remember, this is all over 1. That's the thing we originally ignored. So 1 over something is the same as just flipping it around, doing a reciprocal. So in this case, we can just say x plus 3 or x plus 2 over 2x plus 5. That's what this is the same as. Looking at our answer choices, it's pretty clear that the one that matches is going to be this one. This is just the expanded out version of x plus 3 times x plus 2, but to double check it, let's actually expand it out to make sure we didn't go wrong somewhere. Yep, so that is the same as our numerator. Our denominator is the same, so we know that that is our answer. So this one, in my opinion, is the hardest one in the entire section by far, but that's just me and my lack of exponent knowledge. So this one's using a really sneaky exponent trick that might not be obvious at first. So remember that exponents can be represented as like 2 to the 3rd equals 8. That's 2 times 2 times 2 equals 8. So in this case, since we have an 8 in the numerator, and we know that 2 to the 3rd is 8, we can just replace the 8 with a 2 to the 3rd, and then keep the x there also, over 2 to the y. And this is just a really sneaky trick they like to pull sometimes. If you see something that looks like this with exponents, they probably just want you to expand out the numerator to match the denominator so you can simplify it further. Now going from here, we can change this to just 2 to the 3x over 2y. Now you might say, how are we going to simplify this getting rid of x and y when all we know is 3x minus y equals 12? Well, my friend, that is where more exponent rules come in. So in this case, remember that if you divide by two exponents with the same base like this, it's the same as just like subtracting those exponents from each other. So this would be the same as 3x minus y. And these two things are both just really annoying rules that you have to remember for this. Otherwise, this one would be pretty much impossible. Now we're looking good because we have 2 to the 3x minus y. We already know what 3x minus y is. It's 12. So that would just be the same as 2 to the 12th. This would be one that if I didn't remember those exponent rules and was struggling with for a couple minutes, I would just skip this one and move on, because it's not worth slogging through this one and maybe not even coming up with an answer when you can be doing the entire rest of the test. And to check this one, you know the drill, just plug in everything back and back solve. Now more half word, half polynomial solving equation problems. So if this ax and bx expression equals this expression more in standard form, for all values of x and a plus b equals 8, what are two possible values for c? This is kind of crazy. We don't really know where to start for this one, but if in doubt, just try to expand or alter this original expression in some way. And the first thing that I notice is we can distribute these. So that would be abx squared plus 2bx plus 7ax plus 14 equals 15x squared plus cx plus 14. And notice how I kind of wrote them like that. This is because of a little polynomial trick. So a polynomial is typically like in this kind of form. In this case, the variables are a little switched around, so that gets a little confusing, but we have a coefficient in front of the x squared, the x, and then we have just a constant. So in this case, the constants of our two equations that equal each other are the same. We know that all the constants in front of these variables are going to equal each other because the equations are equal. That's a very important trick to know. So we know that abx squared equals 15x squared. We know that 2bx plus 7ax, which we can rewrite as 2b plus 7a times x equals c of x. And of course we know 14 equals 14. So now this is getting us somewhere because we know a plus b equals 8. So simplifying all these equations even further, we can cancel out the x squareds, we can cancel out the x's, and that leaves us with ab equals 15. 2b plus 7a equals c. And we don't really care about the last equation, since that's not telling us anything new. So now we have 3 equations and 3 variables. So we can solve for c in this case. So let's use substitution in this case. Let's say a equals 8 minus b. And we know a times b equals 15. The real way to do this would be to plug in either the a or b after solving for that expression. So in this case, we could do b times 8 minus b equals 15. So 8b minus b squared equals 15. So to get this into a factorable form so we can solve for b, we can add both sides by b squared, subtract both sides by 8b, and then we have that equals 0. Then back in 7th grade, I was taught to factor using the x method. It kind of stuck with me, and I still use it to this day. So for this, you just need to know what two numbers multiply together to get 15 and add up to get -8. So in this case, -3 and -5. So then we can rewrite this as 0 equals b minus 3 times b minus 5, and that lets us easily solve for b equals 3 or b equals 5. Now, we could do it this way. A less terrible way to do it is to just kind of look at these equations and realize that they're probably only going to give you whole numbers here. They're not going to do any crazy fractions. So what multiplies to 15 and adds up to 8? It's kind of the same thing that we did, just more complicated. So that would give us 3 and 5. So we can either make a 3 or a 5, and then b would be either 5 or 3. So that's probably a much simpler way to do it than this, but it never hurts to check yourself using a different method. So now we know a equals 3 or 5, b equals 5 or 3. You might be tempted to pick a, but it's asking for the two possible values of c, not a and b. So remember that our c is equal to this middle equation here. So c is equal to 2b plus 7a. And now you could go through the process of plugging this in through the entire equation, but that's kind of a lot more work. So in this case, we can just let's plug in a equals 3 first. So we have b equals 5, a equals 3, 10 plus 21 equals 31. Then in the other scenario, we'd have a equals 5, so b equals 3 plus that. So that would be 6 plus 35 equals 41. So our two values of c are 31 and 41. Phew, that's kind of an annoying one. And to check yourself if you did the long way, you can just verify that it makes sense using the short way, or you can retrace your steps, backtrack, and plug in all the values backwards, etc. So now we're on to the free response section. And these ones kind of start out easy again, get a little more difficult at the end. So first one, if t is greater than 0, and t squared minus 4 equals 0, what's the value of t? So this, we can just solve the equation using order of operations. So we can add 4 to both sides. T squared equals 4. Then if we square root this, we have t equals plus or minus 2. It's always good to make sure you have that plus or minus there when you square root something. But in this case, 1, the SAT doesn't let you plug in negative answers, and 2, we have this initial condition, t is greater than 0, so it can't be the negative answer. So we know it's going to be 2. And to check that, we can just plug the 2 back in. We have 2 squared minus 4 equals 0. 4 minus 4 is 0. We're good to go. Now a slightly more wordy one. We have a summer camp counselor wants to find a length x in feet across a lake as represented in the sketch above. The lengths represented by those sides on the sketch were determined to be 1800, 1400, 700, and 800 feet respectively. Segments AC and DE intersect at B, and AEB and CDB have the same measure. What is the value of x? So these are congruent triangles since they have the same angles as each other. Since these are intersecting, they're going to be the same angles, and they give us that this angle is the same. Plus, they're parallel. And don't overthink these geometry problems too much because they're usually going to give you a very simple setup like this. This weird squiggle here is kind of confusing. They just want you to find the length here, not like area or anything. All we have to do is figure out by what factor these two are related to each other. It might be pretty obvious that they're related by a factor of 2 because these two side lengths, 1400 is double of 700, but just to verify that we're thinking of the right sides, we need to redraw this triangle. So the D corner with this angle is going to match up with the E corner, because those are the two that have the same angles. And then in this case, the B corners would match up with each other, and C would be here. So if we redraw this, yep, the 1400 and the 700 sides match up with each other. We're good to go. So in this case, since they're all related by a factor of 2, this side would be 900. The 800 side on this triangle would multiply by 2 to get 1600 on this side. So our answer is x is 1600 feet. And that was kind of our double check for this one. Just be careful you don't multiply the numbers wrong or anything, and you're good to go. Alright, according to the system equations above, what is the value of x? So here we obviously have a system of equations problem. I'm going to solve this through elimination just because of force of habit. It might work better doing it with substitution, whatever. We'll be quick no matter what. So for this, we want to solve for x, so we want to keep the x variable in there. So it's best to multiply by -2 to get rid of the y. So we have -2x minus 2y equals 18. Be very careful. Always multiply that to the other side and be careful of negative signs. Then let's copy down the equation we already have. And then we have the y's cancel out, so we get -x equals 25 minus 18 would be +7, so this would be -7. So we get x equals 7. So to double check this, we could either plug in this 7, these two equations again, make sure the y values are equal, or we can solve the other way if we feel like it. We can rearrange this first equation to be y equals -x minus 9, and plug this -x minus 9 in for the y into the second one. So then we get x plus 2 minus x minus 9 equals -25. X minus 2x minus 18 equals -25. -7 equals -x, and we get the same x equals 7. Be warned, solving the two different methods is still going to give you the same error if you're actually doing this arithmetic wrong. That's something to watch out for. That's how I've made so many mistakes, is just being pretty stupid with my basic arithmetic. That can really cost you points. That's also why the calculator section is maybe a little bit better for this one, especially for those of us who are very error prone. But anyway, we'll call that one checked. Now this one's kind of fun. This is a trig question. So we have a right triangle, one angle measures x degrees. So let's just draw this. We got x degrees for a triangle here, and we are given sine of x equals 4/5. So let's remember our SOHCAHTOA. So this means sine equals opposite over hypotenuse of this triangle. If we take opposite over hypotenuse, we know is 4/5, so we know the opposite side is going to be 4, hypotenuse is going to be 5. And you might recognize this as a pretty classic 3, 4, 5 triangle, not to scale. So then it's asking for cosine of 90 minus x. You wouldn't even have to do any of this if you remembered another trig identity, that sine of x equals cosine 90 minus x if you're in degrees. So literally this is just going to be the same as sine of x, so 4/5 is our answer. But if you didn't remember that, you could pretty easily figure it out by remembering that the angles of your triangle are going to add up to 180, so this angle is going to be 90 minus x. Then if we have cosine of 90 minus x, adjacent over hypotenuse is just going to be the same 4/5, since 4 is the adjacent side to this angle. So 4/5 or 0.8 is our answer. Alright, last problem. We can do this one in a few different ways too. If a equals 5 square root 2 and 2a equals square root 2x, what is the value of x? So we're solving for x here. Most straightforward way maybe to solve this is to just plug in the a to this equation and then solve for x. So if we do that, we get 2 times 5 square root 2 equals square root 2x. So the way radicals work is we can multiply whatever is outside of the radical together, but what's inside has to kind of stay separate, and we get that equals square root of 2x. Now to solve for x, it would be helpful to get this 10 inside, so then we would know, like that would just be the value of x at that point. Since the 2's are the same, the square roots are the same. So to get something back inside a square root, we can just square that. So that would be the same as square root of 100 times square root 2, aka 2 times 100 all over the square root equals 2 times x. We don't even have to multiply those together because we know that in this case x would just be 100. Now the fun little way to check this one is to just realize we can multiply this entire equation by 2 to get 2a, which would be equal to the square root of 2x. That's basically doing the same thing with a slightly different thought process. Let's try it again. So in this case, we're multiplying the first equation by 2 equals 2 times 5 square root 2. Should separate those off. Then we're basically just substituting the square root 2x for 2a instead. and that would be 10 square root 2. And we have the same thing as before, so we can do the same trick in this case, where that is the same as square root of 100, square root 2. We can move it all under to get the same x equals 100. And if this still isn't clear to you that x equals 100 here, you can square both sides, 2x equals 200, and then divide by 2, and get the same thing. So we're good to go. We checked all these. So I find that by trying to solve these in as many different ways as I can think of, that really makes my mind work in different ways and helps me avoid more careless mistakes than if I just rushed through and solved it in one way. Now, obviously, this takes a lot of practice, and depending on how quickly you recognize the type of questions and how fast you are at doing mental math, this might not be feasible for you. So I would use this double check method if you're consistently finishing within the time frame. But if you're struggling to finish on time, I would just go ahead and try to get through every single problem first, and then maybe go back and do the double check method. It's all about balancing your time as much as possible. So if you do the double check method, but only get halfway through the test, that's no good. Even if you would have only gotten 75% of them right from your first run through, it's still better to get through as many of these as possible. That's like your first priority. But I find that once you're at a high level and can solve all of these pretty easily, this is definitely a great way to ensure that you're not making any careless mistakes. So next time we'll work on the calculator section of the math section. And until then, thanks for watching. Be sure to like and subscribe. Go check out Prep Scholar if you haven't yet, and see you soon!